Alrighty, this is your video for 13.1. This is titled Area of Parallelograms and Triangles. This is going to be probably something that a lot of you guys are going to enjoy because it's going to be a lot of formula-based problems. The first lesson is going to be over area of parallelograms and triangles. And then when we move on to the next section, we'll do areas of trapezoids and rhombuses and kites. We'll move over to the regular polygons. So we're going to kind of go back to some of the things that we talked about in Chapter 6 with our polygons and our quadrilaterals and all the pentagons and all that stuff. And then we're going to get into perimeters and areas, and we're going to add in some trig in there as well. So our first lesson, 13-1, it's going to have a couple important formulas, but first I want to go over some vocabulary. You need to be familiar with base, altitude, and height. The base of a parallelogram, or really the base of any figure, is always the side that is perpendicular to the height. So technically, depending on where the height of the figure is drawn, allows you to know which side is the base. So in this case, they drew the base for you in red, and they wrote the word base in red. And then you see altitude. Altitude is actually the height. The height is just considered what's called the length of the altitude. So the altitude and the height are the same thing. And we've had to use this before, so this hopefully doesn't sound familiar, or doesn't sound unfamiliar to you. So basically, for a parallelogram, you have a base and a height, but we call the height altitude, so it can be called either way. The second one you need to remember, we've talked about this, you've learned this a while back, but in other classes too, but just in case you forgot, the equation for the area of a rectangle, which is base times height. Remember, base and height are always perpendicular, so technically for a rectangle, rectangle has 90-degree angles. This would be our base, and this would be our height. The next one you need to know is the area of a parallelogram, and I did not mean to write area. Parallelogram. The equation for the area of a parallelogram is also base times height. But the difference for this, and as you can see in the picture above, the height is not this side. That is just part of the drawing of the figure. This right here is our height. So basically this is H, which would make that B. Now because it's a parallelogram and this side's equal to this side, this could also be B. The next one you need to know is the area of a triangle. So we've used this one recently, so this shouldn't be a new formula to you. A is equal to base times height over 2, or you can say 1/2 base times height, where a triangle, if it's not a right triangle, then you would have to draw the height in there, and so this would be our height, and this down here would be our base. The last thing that you need to know is what's called the area addition postulate. The area addition postulate is basically a postulate that tells you that if the area of a region, if you're given the area of a region and it's equal to the sum of the areas of its non-overlapping parts. So the area of a region is equal to the sum of the areas of its non-overlapping parts. So that's like if you have two triangles like connected to each other, you could take the area of the left triangle and then take the area of the right triangle and add them together. And we did that the other day actually. We had circles with sectors drawn and overlapping, and we would find the area. It's also considered a composite figure. So the area addition postulate. You can get those exact words that I read online if you'd like to in your textbook. So our first example is going to be finding the area of a parallelogram. In this example that I'm going to draw for you, we're going to have a parallelogram, and we're going to find the area based on the given measurements. So in this picture, we have a lot of information here. We have 4 inches being there. This is 5 inches, and the slanted side is 4.5 inches. The key thing here is that you notice that there is a right triangle in this picture, which means that if they don't give us the height, we can use Pythagorean theorem to find it. Or if they don't give us the full base, we can use the Pythagorean theorem to find it. But in this particular question, that's not necessary. The formula that we learned was base times height. We know that the base is 5, and we know the height is 4. So we know that our final answer is going to be 5 times 4, which is 20. So my area is 20 inches squared. Okay, so our next example is another parallelogram question, but we are needing to find DE. So basically what you have here is a parallelogram that has a height that we don't know the length of, and it has a triangle that's a right triangle out here. Now, the nice thing about this is that we can find the area of the parallelogram if we take this and we turn it this way. The height is 9 and the base is 13. So if we find what the area is, then we can very simply figure out what the height of the parallelogram going this way is. So basically, area is base times height. In the way that I turned it, the area was equal to 13 times 9, which is 117. From there, we can use our area equation again, but this time A is 117, B is 9.4, and H, we don't know. Divide both sides by 9.4, and you get about 12.4. So one of the key things is that this triangle that I used right here that I'm kind of coloring in, that is a triangle that allowed me to still find the area of, because it was perpendicular to the base going this way. So if you look, this was 90 degrees right here. So this was height and this was base. Okay, it was still perpendicular. We just had to extend the base out further. So sorry, that's kind of messy. Hopefully that kind of makes some sense. Okay, so we were doing area of triangles last week with chapter 12 and chapter 11. So not chapter 12, sorry, but chapter 11 we were. So if you need some extra examples, I'd be happy to provide them for you. But I want you guys to do a little bit of research on your side, looking up examples of composite figures. We've done them before, but I want you to go either in the book, you can go online, you can make up your own. I've talked about composite figures before, like for example the paint or the key in the basketball court, but I want you to look for an example and I want you to bring it to class. Now if it's not completed, like if it's not solved, then you need to solve it, but I want you to bring it to class with you along with your notes. Have a great evening and I'll see you soon.